Ladies and gentlemen, I would like to thank you for inviting me and for attending my presentation. I present to you a summary of our development strategy and our activities for the moment. The CRMN was administratively created in 2012. We started occupying the new building in September 2014 with the arrival of the first researchers. It is therefore a young research center. Let me introduce you to where we are. Innovation City in Sousse Technopole in Tunisia is a new innovation hub located near the city of Sousse and called Innovation City. It is a knowledge triangle within the framework of the national strategy of smart specialization in mechatronics. It is a pool of skills and a hub where research, education, and innovation interact. We can, with partners, concentrate skills in one place and accelerate technological growth, and also with national and international clusters and partners to animate the ecosystem. Mechatronics in Tunisia is a fast-growing sector with more than 1,000 companies and 130,000 jobs. It is the leading exporting sector with a rate of 45% of total manufacturing exports. It is therefore a promising field of activity and with strong needs for innovation and technology with trends such as Industry 4.0, electric and autonomous cars, IoT, and artificial intelligence. Tunisia's scientific potential has several advantages. Geopolitical potential with proximity to Europe, the MENA region, and well anchored in Africa. It is a democracy and culturally open to the world with a common practice of foreign languages. Tunisia is also a member of COMESA, Common Market for Eastern and Southern Africa. It is well associated with several titles with Europe. As an example, Tunisia has been an associated member of the European H2020 research project since 2016. Tunisia has a strong scientific potential with 39 research centers, 600 university labs, 60,000 graduates per year. The third of them is in basic or engineering science. Tunisia is the first Africa in scientific publication per capita and 49th in the world in number of articles. Tunisia also has a good publication rate on nanotechnology. It's fourth in number of nano articles by GDP based on state nano site web. Finally, Tunisia is well ranked in Global Entrepreneurial Index with an increased desire to improve our innovation system. Nanotechnology innovation research provides a fundamental understanding of phenomena and materials at the nanometric scale. It allows to create and use structures, devices, and systems which have new properties and functions due to their small size and structural organization. In fact, elements at a scale of less than 100 nanometer can have new innovative electrical, thermal, chemical, physical, optical, and multidisciplinary properties, as Nanocar awarded at the 2016 Chemistry Nobel Prize. In line with our mission, our national priorities, new technological trends, IoT, Industry 4.0, artificial intelligence, etc., but also in accordance with the United Nations Sustainable Development Goals, and thanks to our privileged international links, we have built our research strategy on three axes: infrastructure and process for micro and nano sensors and systems, R&D programs on nano and microelectronics for IoT, medicine, space, security, textile. with particular care in the scientific study of the new needs of our economy and technological changes and trends in the world. Since its official creation decree in 2012, and in order to strengthen research infrastructures and industrial capacity in microelectronics and nanotechnology in Tunisia, the missions of the CRMN have been clearly defined. Thus, the CRMN team has implemented a strategy and a clear research policy that was deployed on 4 types of actions in accordance with its official missions. Develop scientific research and the appropriation of technologies with the framework of funded projects. Provide science and technology experience and training to our staff and young researchers. Encourage and contract partnership with public and private institutions and companies both nationally and internationally. Establish high-tech platforms for operational and complete scientific and technological infrastructure. To diversify and complete our infrastructure, we are currently installing 7 technological platforms: a computer-aided design platform for virtual design and prototyping, an electronic test and qualification platform, a prototype mechatronic manufacturing platform, a nanomaterial synthesis platform, an optronic instrumentation platform, a clean room for micro and nano fabrication platform, finally a high-tech nanoscopy platform. So a computer-aided design platform consists of 8 computer servers and 28 PC stations under Linux and Windows. We have several open source electronics design automation tools and full suites of Cadence and Mentor CAD tools. CRMN is a member of the Europractice program with 640 European universities. It is an initiative which aims to access the state-of-the-art in microelectronics and the methodologies and technologies of design of electronic systems for integrated circuits, photonics, MEMS, FPGA, and systems for non-commercial research and teaching to share lessons and know-how. The electronic test and qualification platform is based on sophisticated equipment, a station with 2 RF and 4 DC probes in a metal black box for testing circuits before packaging, and with high functionality up to 40 GHz. Also, several test instruments for very high frequencies on bench of for 6 GHz and another for 40 GHz for IoT, 5G or even 6G applications. A set of instruments for the characterization of impedances, the extraction of parameters, and the analysis at very low powers and low currents. Mechatronic fab platform, we bring together in the same place various prototype manufacturing equipment such as 3D printer, PCB developer, mechanical workshop, and CNC machines. Nanomaterial platform is intended to the synthesis of nanomaterials and the functionalization of certain types of sensors. We bring together various equipments for chemistry and biology: high-speed microcentrifuge, electrospinning apparatus, ultra microbalance, and other furnaces. In the platform of optronics intended for the optical characterization for materials, we have several equipment too: ultraviolet visible spectrophotometry, a Fourier transform infrared spectroscopy, zeta sizer, metricon, which is a prism coupler for quickly measuring refractive indices and thickness. The micro and nano fab is a clean room ISO 6 class 1000. It is now under construction with a size of 150 meter square. This platform is intended for the fabrication of micro and nano system on silicon chips with different processes: laser lithography, chemical vacuum deposition, wet and dry etching, diffusion, and thermal treatment. Finally, the nanoscopy platform is currently made up of two high-performance equipment: a scanning electron microscope uh, called APRIO-S with EDS X-ray detectors for composition analysis and EBSD camera for crystallographic orientation mapping, and an AFM Raman analysis, which is combined on a single microscope system with four spectroscopy modes. On one hand, it provides topographic, mechanical, thermal, electrical, and magnetic properties. Also, leading research and development programs on nano and micro technology is an important objective. It goes through identification of research projects and participating to national and international calls with partners who will implement and exploit research results in accordance with national or international priorities to fund adequate funding, and having to advance our own technological readiness level step by step. Currently, the CRMN leads several research projects: nanosensor for medical applications. One is called one for COVID and other for cancer. Counter-terrorism security system called PACT, and another project called FACT, fabrication and application of CubeSat in Tunisia, which aim to help us to access to space technology through nanosatellite programs, and the development of a smart agriculture experience. The CRMN carries out several network actions and enhancement of its resources and staff. We go up in production and activity by offering several conventions, conferences, and by organization own periodic events called Jasmina, journée d'actualité scientifique en microélectronique et nanotechnologie. We also participate in brainstorming committees to propose and manage various projects with our network of academic and industrial partners, and also official department of research, agriculture, defense, environment, health, and security. So this slide presents our MINANET partners network. It is composed by Tunisian universities as well clusters of companies in electronics and mechatronics. It is also composed by international cooperation agencies, universities, and some United Nations agencies with whom we have several projects and activities. This slide presents our international relations network, which we have visited, or those who have visited our center among the diplomatic corps and international visitors. In this context, we note that we represent Tunisia, and especially within the framework of space and nanotechnology research policy in Europe, through our national contact point or program committee members of the H2020 program. We also host the EEE Chair of Tunisia Nanotechnology Council and another in Microwave Theory and Technique Society. CRMN is also member of AUF, Agence Universitaire Francophone. We take this opportunity offered by the African Commission for the Economy of the United Nations, that we warmly thanks through this forum on nanotechnology, for expressing our strong interest in the integration of a new African consortia for new projects, exchanges, and challenges. At the end, I would like to express to you my joy and pleasure to present you this young research center and SUS Technopole, hoping to develop together new opportunities for cooperation and exchange. And thank you very much.